Good morning, my dear students. A very good morning to all of you, and welcome to this session. In today's session, we are going to talk about the intermolecular forces. And what are the intermolecular forces? Intermolecular forces are the dipole-dipole interaction, the weak van der Waals forces, and hydrogen bonding. That's what we are going to talk about. Now, you need to remember that these are the forces in which most of the students make a mistake because these forces are extremely important for organic chemistry, inorganic chemistry, and even when we talk about the gaseous state and solid state and whatnot, the physical chemistry as well. So, these are extremely important. Just remember, these are weak forces, but in the universe, the weakest force is gravity, but gravity is the supreme ruler in the universe. As we say, meek shall rule the world. So we are going to get along with it. Okay, so we have Prerna, Ananya, and Radhika. So we have three people watching at this moment, and we have got 8 likes. Where are the others? Okay, let's begin over the session. We have the Elixir Dropper batch starting from 16th of August. Clear? You can enroll with it using the code AVLIVE. So use the code AVLIVE and join with it. Hansika, welcome. How are you? Hansika, you have joined the group, the Telegram group. Okay, so this is what we have in-depth analysis of PYQs, revision classes, exam strategies, mentor-mentee programs, mind maps. That's all are going to be present in the Elixir Dropper batch. Botany, chemistry, and zoology. Botany at 6:30, chemistry at 7:30, and zoology at 9 p.m. So quickly join this particular batch. You can go on with the complete Unacademy subscription, or you can go to the store and get the course subscription. So both things are possible. So let's join with it. Elixir Droppers batch. Okay. Use the code AVLIV. And you can get all the information from this particular phone number 636695073626. Good morning. So that's what me. And let's get along with the intermolecular forces. Now, when we talk about the intermolecular forces, we have another word which we call as intramolecular forces. What is the meaning of intra and what is the difference between intra and inter? Inter is, let's say we have a molecule, carbon, hydrogen, 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 hydrogen. You know that this is a molecule called methane. Now, there is a force between carbon and hydrogen. This is within the molecule. This force is intramolecular. This is what we call as the force which is intramolecular, within the molecules, within the molecule. Okay. Then there is another methane molecule. Now, between these two methane molecule also there is an attractive force. Now, this force which is acting between two different methane molecules is what we call as intermolecular. Okay, that is between the molecules. Or if we have more than two, then in that case becomes among the molecules. So I hope you are very much clear about intra and inter. What is the meaning of intramolecular and what is the meaning of intermolecular? You are very much clear about it. Fine. Yes, the students are sending me their video, the notes. You have to send your notes to me so that we can verify it, we can judge it, we can rectify it if any requirement rectification is required. जी तेरा बेटा अक्षय है फायजा गुड इवनिंग okay. So that's what we have is what is the meaning of inter and intra. Now let's talk about the very first force. अच्छा एक बात का ध्यान रखना all forces in chemistry are electrostatic in origin. राधिका मित्तल अगर एक्टिवेशन एनर्जी जीरो होगी तो टेम्परेचर इंक्रीज या डिक्रीज से रेट ऑफ रिएक्शन पर असर नहीं पड़ेगा यू आर लुकिंग एट अ डिफरेंट क्वेश्चन एंड यू आर आस्किंग मी अ डिफरेंट क्वेश्चन ओके बट एक्टिवेशन एनर्जी जीरो होती नहीं है all forces in chemistry are electrostatic in origin that we are talking about electrostatic forces that electric forces Ananya Sarkar, beta, if we increase the temperature to a very high value, then in that case, the energy of the reactant changes. And if the energy of the reactant changes, then in that case, the activation energy also changes. But we are not talking about a very high change in temperature. We are talking about only a small change in temperature that is 10 or 20 degrees Celsius. With that, we can consider the activation energy to be a constant. So be very clear about for a small change in temperature. We are not talking about a large change in temperature. Is that clear? So let's talk about all forces in chemistry as electrostatic in origin. Okay. Now we are going to talk about something called a pole. What is the meaning of a pole? Pole is something like a distinct region. A region which can be distinguished from the other places, the region which can be identified. That is what we call as a pole. Clear? We talk about the North Pole, we talk about the South Pole, we talk about the pole in a particular goal का pole जो होता है वो any flag pole, anything which is distinct, which is different from others, which is easily identifiable. The distinct region and identifiable region. Okay, so that's what we call as a pole. Now in chemistry, we talk about the pole as a region of high or low concentration in a uniform distribution. Okay, a region of high or low concentration in a uniform distribution. We have the entire uniform distribution, and there certainly we get some high concentration or a low concentration. Again, that can be easily distinguished, which can be easily identified. So, Mitra, we are going to talk about hydrogen bonding in detail. Don't worry about it. We are going to do it. So, that is what we have as a pole. That is what we have as a high concentration or low concentration region. Is it clear? So, that is what we have as pole. Now, we get along with something called a dipole. Dipole. Dipole would mean two equal but opposite poles. That is two equal but opposite region of concentration. It could be something like the North Pole and the South Pole of the magnet. It could be a positive and the negative in the electricity. That is what we call as a pole. So that is what we have as two equal and opposite poles is termed as a dipole. Clear? Now we talk about something called the electric dipole. Electric dipole. So let's have the definition of electric dipole. Electric dipole by definition is two equal and opposite charges separated by a small distance. Two equal and opposite charges separated by a small distance. That is what we call as an electric dipole. Here we can have a small charge. Here is another charge. Okay. Now, when you talk about these two charges, these are the two charges we have. Here is going to be a positive charge. Here it is going to be a negative charge. And this is the small distance between them. Please remember the distance is not negligible. It is a significant distance. It is a measurable distance. It is a visualizable distance. But still, it is a small distance in comparison to the distance from the viewer. or which we can call as observer. Now, this distance, what we take in chemistry is this distance is what we call as r, and this distance is x. So x is much larger than r, but r is not insignificant in comparison to x. R has some magnitude, r is somewhere comparable to x. So that is what we call as the small distance. Clear? Now, so that is what we call as an electric dipole, two equal and opposite charges separated by a small distance. Now, when we talk about this electric dipole, we talk about the strength of the dipole. Okay, we have something like strength of the dipole. Now, talking about the strength of the dipole, what exactly it is dependent on? The strength of the dipole is proportional to a quantity, which is called dipole moment. The strength of the dipole is called the dipole moment. Now, dipole moment is a vector quantity, is represented by mu. Now, this mu is equal to the magnitude of charge separation multiplied by the displacement vector. Okay, R is the displacement vector. Is this clear? So that is what we have as the displacement vector. That is what we have as the dipole moment. Now, when we talk about the dipole moment and the displacement vector, now we need to talk about what exactly is being displaced. भाई डिस्प्लेसमेंट वेक्टर की अगर हम बात करें, कुछ तो डिस्प्लेस हुआ होगा ना, कुछ तो मूव किया होगा ना. Okay. Now, in physics, we consider the movement of positive charge. In physics, we consider the movement of पॉजिटिव चार्ज. अब पॉजिटिव चार्ज की अगर हम मूवमेंट की बात करें, देन इन दैट केस द पॉजिटिव चार्ज इज गोइंग टू मूव फ्रॉम द स्पीशी. देखो, लेट अस से वी कंसीडर टू न्यूट्रल स्पीशी. अगर हम एक स्पीशी में से पॉजिटिव चार्ज निकाल देते हैं, दैट स्पीशी इज गोइंग टू गेट नेगेटिवली चार्ज, और हम दूसरी स्पीशी में डाल देते हैं, तो दैट स्पीशी इज गोइंग टू गेट द पॉजिटिव चार्ज. सो मूवमेंट ऑफ द पॉजिटिव चार्ज इज गोइंग टू बी फ्रॉम द फाइनल नेगेटिव टूवर्ड्स द फाइनल पॉजिटिव. तो अगर हम फिजिक्स की बात करते हैं, तो in case of physics, the direction of the dipole moment will be from negative towards positive. So this is what we have as physics. Any confusions, anybody? So here in case of physics, we talk about the direction from negative towards positive because we are talking about the movement of positive charge. Okay. In chemistry, we consider movement of electron. Okay. Now, since we consider the movement of electron, the electron moves opposite of positive charge. So, direction of dipole moment is from positive to negative. Is this clear? The direction of the dipole moment is from positive to negative. Any confusions? But now you need to understand that when we talk about in केमिस्ट्री के अंदर जब हम डायपोल मोमेंट की डायरेक्शन लिखते हैं या डायपोल मोमेंट बनाते हैं, देन इन दैट केस वी यूज अ डिफरेंट सिंबल. And that symbol that we use is this arrow, but what we do is हम यहां पर एक पीछे क्रॉस डाल देते हैं. So this is the symbol which is used in chemistry. Clear? समझ में आ गया? तो इस तरीके से आपको डायपोल मोमेंट के वेक्टर का जो साइन है उसी से पता चल जाएगा कि वी आर टॉकिंग अबाउट द केमिस्ट्री डायपोल मोमेंट और वी आर टॉकिंग अबाउट द फिजिक्स डायपोल मोमेंट. क्लियर? Now, let's talk about the further things about the dipole moment. Let's talk about the units of dipole moment and let us talk about how we use it. Okay, so let's talk about the units of dipole moment. Clear? Now, as you can very well understand, the dipole moment is equal to the magnitude of charge multiplied by the displacement vector. Now, let's talk about the SI unit. So, the unit of the charge in SI units is coulomb. And the unit of the displacement is meter. So the unit of the dipole moment in SI units is coulomb meter. Okay. Then we can have the unit of the dipole moment in CGS unit. So this is in the SI units. If we talk about the CGS unit, the unit of the charge is ESU. Now ESU stands for electrostat units. Electrostat units. ESU centimeter. So it is in CGS units. X क्या था इस स्लाइड में? This X is the distance of the viewer from the dipole. ठीक है? So these are the two units that we have of the dipole moment. चलो अब एक छोटा सा क्वेश्चन रखें. Calculate the dipole moment developed when an electron moves from one atom to other across the bond length of 1 angstrom in SI and CGS. Okay, so the charge of the electron is equal to 1.6 into 10 raised to power minus 19 coulomb, which is equal to 4.8 into 10 raised to power minus 10 ESU. Give me the value. In the CGS unit and the SI units. जल्दी से आंसर दो. आंसर. मुझे अभी तक आंसर नहीं मिला किसी का भी. Just remember, 1 angstrom is equal to 10 raised to power minus 10 meter, and this is equal to 10 raised to power minus 8 centimeter. So give me the value. इसमें कोई मुश्किल वैल्यू तो है नहीं. So this mu is equal to Q into R. That will be equal to 1.6 into 10 raised to power minus 19 coulomb into 10 raised to power minus 10 meter. That is equal to 1.6 into 10 raised to power minus 29 coulomb meter. Okay, and that's equal to 4.8 into 10 raised to power minus 10 ESU into 10 raised to power minus 8 centimeter. That is equal to 4.8 into 10 raised to power minus 18 ESU centimeter. Is this clear? What are you doing? You are not solving it. Fine. Now, initially when we talked about dipole moment was talked in CGS units. तब CGS unit की ही बात की जाती थी और कोई बात नहीं की जाती. So when we are talking about the CGS unit, they understood that whenever we are going to talk about the molecule, this 10 raised to power minus 18 ESU centimeter will always be there. Because हम इलेक्ट्रॉन की बात कर रहे हैं, हम चार्ज डिस्टेंस की बात एंगस्ट्रॉम में ही कर रहे हैं. तो 10 raised to power minus 18 ESU centimeter तो हर बार आएगा ही आएगा. So what they did was, this 10 raised to power minus 18 ESU centimeter, इसे एक नाम दे दिया गया, and this was called 1 dBi. This was called 1 dBi. And what is this 1 dBi actually equal to? Now this becomes 10 raised to power minus 18 ESU centimeter, so this actually became 4.8 dBi. अनन्या, इतना सिंपल था तो पर आपने किया क्यों नहीं? हर चीज सिंपल ही होती है जब तक आप करते नहीं हो. ठीक है, जो चीज हो जाती है वो तो सिंपल हो ही जाती है, फिर उसके पहले आपने किया क्यों नहीं? तो अगर इतना ही सिंपल था तो चलो एक छोटी सी बात बता दो. अनदर क्वेश्चन, कैलकुलेट the value of one debye in SI units. SI यूनिट्स में एक डिबाई की वैल्यू बता दो। आंसर यहां पर लिखा हुआ है। What is the value of one debye in SI units? बताओ बताओ बताओ। ऐसे सॉल्व होगा। 4.8 debye is equal to 1.6 into 10 raised to power minus 29 coulomb meter. ठीक है? So 1 debye would be equal to 1.6 into 10 raised to power minus 29 divided by 4.8 coulomb meter. कैंसिल करें तो कैंसिल करेंगे तो ये कट गया, ये कट गया, यहां पे ये 1 आ गया, यहां पे ये 3 आ गया. सो दैट इज इक्वल टू 1 by 3 into 10 raised to power minus 29. And that becomes equal to 3.33 into 10 raised to power minus 30 coulomb meter. कोई प्रॉब्लम? Does anyone have any confusion about it? तो ये हमारे पास डायपोल मोमेंट आ जाता है. क्वेश्चन सामने लिखा हुआ बेटा हंसिका. Question is written right in front of you. चलिए. Now let's talk about a molecule. Dipole in molecules. Okay. Let's consider diatomic molecules. ऐसा कुछ नहीं है कि डायपोल में diatomic molecules होने चाहिए. कितने भी atoms हो सकते हैं. Not a problem with that. But let us consider simple cases of the diatomic molecules. ठीक है. When we talk about a diatomic molecules, when we talk about the diatomic molecules, हमारे पास दो तरह के diatomic molecules हो सकते हैं. हमारे पास हो सकता है AA, that is homonuclear. होमोन्यूक्लियर का मतलब यह है सेम इलेक्ट्रोनेगेटिविटी. सेम इलेक्ट्रोनेगेटिविटी. सेम इलेक्ट्रोनेगेटिविटी का मतलब हो गया नो चार्ज सेपरेशन. ठीक है. सेम इलेक्ट्रोनेगेटिविटी, नो चार्ज सेपरेशन. अब नो चार्ज सेपरेशन की अगर बात कर ली हमने तो देयर इज नो परमानेंट डायपोल मोमेंट. अब एक बात का ध्यान रखना, द इलेक्ट्रॉन्स आर नॉट स्टेशनरी, दे आर मूविंग. So if they are moving, there may be some instantaneous dipole moment. Clear? So there may be some instantaneous dipole, but overall there is no net dipole moment. It is going to be non-polar molecule. Clear? So there is not going to be any dipole moment. It is going to be a non-polar bond, and it is going to be a non-polar molecule. Non-polar bond, and here we have non-polar molecule. सीधी सी बात है, पोलर का मतलब यह है कि जहां पे पोल्स हों. नॉन पोलर का मतलब है जहां पे पोल्स ना हो. सो दिस इज अ नॉन पोलर मॉलिक्यूल. क्लियर? So that is what the first thing happens to be. It's a non-polar bond, it's a non-polar molecule. Fine. And then there could be heteronuclear diatomic molecule. Let's say we have A and B. Now this is heteronuclear. Okay. So heteronuclear का सीधा सीधा मतलब ये है different electronegativity. ठीक है? So heteronuclear is different electronegativity. अगर different electronegativity है, तो there will be charge separation. Okay. And therefore there will be a dipole moment. And therefore it will be a polar bond, and there will be a polar molecule. कुछ पूछना है इसमें? ठीक है? Now, okay, let us consider this AB molecule and consider B more electronegative. So B is more electronegative. तो होगा ये कि ये जो चार्ज है ना, यहाँ पे जो इलेक्ट्रॉन क्लाउड है, that will be shifted more towards B. So B is going to get a delta negative charge. Remember, B की इलेक्ट्रोनेगेटिविटी ज्यादा तो है, पर इतनी ज्यादा नहीं है कि इलेक्ट्रॉन पूरा B की तरफ शिफ्ट हो जाए. Electronegativity of B is high, but it is not that high that the entire electron pair shifts to B. So here, B is going to be delta negative and A is going to be delta positive. So there is a partial shift of the electron. Partial shift of electron. Yeah. Now, the shift of the electron would mean that there is going to be some part of the ionic character. Now, partial shift of the electron means some ionic character is okay. So what we can actually know is that there is a fractional charge shift. Fractional charge shift. So it is going to be mu observed. Now remember, dipole moment is an observable, measurable quantity. We can actually observe the dipole moment. We can actually measure the dipole moment. So this mu observed divided by mu calculated is equal to the fractional charge shift. You can even talk about the percentage ionic character. Percent ionic character. Percent ionic character is again mu observed divided by the mu calculated multiplied by 100. That gives us the percent ionic character. Now, percentage ionic character, the question may be asked on this because this is also given in NCERT. Okay, now let's have a question. For a molecule AB, mu observed is equal to 1.5 dBi. Mu observed is 1.5 dBi. Bond length is 1.2 angstrom. Okay. Considering one electron involvement, calculate percent ionic character. Calculate percent ionic character. Can you solve it? Choose a unit. Choose the SI unit, or you can use the dBi, you can use ESU centimeter. Choose one unit because numerator and denominator must have the same dimensions. Whoever has not liked the session, go ahead and like it. अब एक बात का ध्यान रखना, the calculated will be equal to 4.8 into 1.2 into 10 raised to the minus 18 ESU centimeter. Or it is going to be 1.6 into 1.2 into 10 raised to the power minus 29 coulomb meter. ठीक है? Or you can simply say it is going to be 4.8 into 1.2 dBi. कोई सा भी यूनिट यूज कर लो. And observed will be equal to 1.5 dBi, which is given, or it is going to be 1.5 into 3.33 into 10 raised to the power minus 30 coulomb meter. Okay, or you can write it as 1.5 into 10 raised to power minus 18 ESU centimeter. So it's up to you which unit you are going to use, and you can get the same answer. आंसर में कोई दिक्कत नहीं आएगी. Okay. So when you talk about the final calculation would turn out to be 1.5 upon 4.8 into 1.2 into 100. That will be the final calculation that you are going to get. आंसर निकाल के जल्दी से बताओ मुझे क्या आंसर आ रहा है, कितना परसेंट आयनिक कैरेक्टर आ रहा है. आंसर दो भाई, कितना परसेंट आयनिक कैरेक्टर है इसमें. सॉल्व करो रन्या, सॉल्व करके आंसर दो. आंसर नहीं दिया सॉल्व करके. Now we have something called the dipole interaction. Okay, the interaction between the polar molecules is termed dipole interaction. कोई बात नहीं अक्षर, नेटवर्क इशू हो रहा है तो कोई बात नहीं, ये रिकॉर्डिंग देख लेना, सारी की सारी चीज अवेलेबल है. So this is what we call as a dapple dapple interaction. Now we get along a little bit further. Dapple dapple interaction की और बात करते हैं. Let us have the thing called, what is the meaning of the polar molecules? Polar molecules. Okay, सबसे पहली चीज, homonuclear diatomic molecules have non-polar bonds and molecules are also non. ठीक है. दूसरी बात, heteronuclear diatomic molecules have polar bonds and molecules are. Is this clear? So they have the polar bonds and the molecules also are polar molecules. Okay. Then we can have the polynuclear atoms, more than two. So when we talk about that, let's talk about certain examples. Let's say we talk about the same example. Let's say we talk about BeCl2. We make the structure of BeCl2. We have Be, we have Cl, we have Cl. Now, when we talk about BeCl2, we have the bonds. Here, it's going to be a dipole moment in this direction. And there is going to be a dipole moment in this direction. Okay. There are two polar bonds. There are two polar bonds. Now, when we have the two polar bonds, then in that case, it's going to be having two equal and opposite dipole, two equal and opposite dipole moments. नहीं बेटा 4 PM पे सेशन नहीं है. There are two equal and opposite dipole moments. Okay. जब मैं equal and opposite dipole moments की बात कर रहा हूं तो ध्यान रखना dipole moments are vector quantities which can add, subtract, and give resultant. Is this clear? So here, net dipole moment is, so it has polar bonds yet non-polar molecule. ठीक है? So यहाँ पे polar bonds हैं but molecule non-polar है. So that is what we have as BeCl2. In the same manner, if I talk about BF3, I talk about SO3, I talk about NO3 minus, CO3 2 minus, all have polar bonds, but non-polar molecule. The same is true for CH4, same is true for CCl4, same is true for PCl5, same is true for SF6. So all these have polar bonds, but they have non-polar molecules because the dipole moments cancel each other. इनके angles इस तरीके से बने हुए हैं कि वो सारे के सारे angles एक दूसरे को cancel कर देते हैं. So that is what we have as the molecules. Now let's talk about the example of the polar molecules जो actually polar होते हैं. Let us say we talk about something called H2O, water. जब हम water की बात करते हैं तो this is the oxygen. Here we have hydrogen. Here we have hydrogen. And here we have two lone pairs. तो यहां पे जब हम dipole moments की बात करते हैं तो there is going to be one dipole moment in this direction. There is going to be another dipole moment in this direction. There will be another dipole moment in this direction, that is from the atom to through the lone pair. Another dipole moment in this direction. Okay, that is from nucleus through the lone pair. And then there would be a resultant dipole moment. Any confusions here? So there is going to be a resultant dipole moment in the case of water. Let's take the example of ammonia. And let's take the example of NF3. Now, this is very famous examples. These are always given in every book. So these are the kind of examples. So here we have ammonia, nitrogen. Here we have hydrogen. Where we have hydrogen, hydrogen, and the lone pair. And this is NF3. Here we have fluorine, 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 and electron pair. In case of ammonia, this goes in this direction. So there is a net dipole moment in this direction. All dipole moments add up. When we talk about NH3 and F3, there is a dipole moment in this direction. There is a dipole moment in this direction. And there is a dipole moment in this direction. Okay. And here is a dipole moment in this direction. So the net dipole moment is actually a small dipole moment in this direction. So we can say NH3 is more polar than NF3. So are we clear about what the dipole moment is and where the dipole moment works? Anyone has any kind of confusions here? जिसने भी लाइक नहीं किया जल्दी से लाइक कर दो सेशन को. Now let's get along with something called hydrogen bonding. Now, hydrogen bonding is a special case of dipole moment. Okay. अब एक बात का ध्यान रखना, hydrogen has low electronegativity of 2.1. Electronegativity of hydrogen is 2.1. ठीक है? Less than chlorine or chlorine of 3. ठीक है? But has very high ionization energy of 1312 kilojoule per mole. Okay? And that is higher than क्लोरीन से इसकी आयोनाइजेशन एनर्जी ज्यादा है, इलेक्ट्रोनेगेटिविटी कम है. Peculiar case because hydrogen has only one electron and does not want to lose it. इलेक्ट्रॉन छोड़ देगा तो बच जाएगा प्रोटॉन, और प्रोटॉन इज हाईली अनस्टेबल. आप ये कह सकते हो कि एक ऐसा भूत है जिसके पास सिर्फ एक लंगोटी है, वो उसको पकड़ के बैठा हुआ छोड़ता नहीं है. So that is why the electronegativity of that is why the electrons to be released from hydrogen are extremely difficult. So bond of hydrogen with highly electronegative atoms is highly polar but covalent. आयनिक नहीं बनता. Ananya Sarkar, will have you already done the NCRT questions? We are going to do the questions in the evening for this particular chapter, bonding. इसीलिए तो स्पेशल केस है, क्योंकि हाइड्रोजन के अलावा ऐसा कोई और करता नहीं है. आई एम नॉट सेइंग एक्सेप्शनल केस, आई एम सेइंग स्पेशल केस. ठीक है. सो हाइड्रोजन हैज हाई पॉजिटिव charge but remains covalent. हाँ राधिका, इसके क्वेश्चन की स्पेशल क्लास रखेंगे बॉन्डिंग के. ठीक है. So let's talk about the definition of hydrogen bonding. Okay. The interaction between hydrogen attached to a very high electronegative atom. Now, this highly electronegative atom could be fluorine, could be oxygen, could be nitrogen, or it could be something like carbon attached to 3-chlorine. Okay. So electronegativity is not something that it has to be for the atom only. It could be because of the other atom attached to the atom also. And an atom having a high negative charge and at least one lone pair. And that could be fluorine, could be oxygen, could be nitrogen, could even be chlorine. Is termed hydrogen. Is this clear? Now, hydrogen bond is stronger than simple dipole dipole interaction, but weaker than a proper covalent bond. ठीक है? It is stronger than simple dipole-dipole interaction but weaker than a proper covalent bond. एक proper covalent bond से weak होता है लेकिन एक normal dipole-dipole interaction से strong होता है. ठीक है? अच्छा, अब एक बात. Hydrogen bond is formed by lone pair of one atom and anti-bonding empty orbital of hydrogen. So it is directional. हाइड्रोजन बॉन्ड एक स्पेसिफिक डायरेक्शन में बनता है. Okay? Now there are two types of hydrogen bond. And these are first one, intramolecular. ठीक है? Both hydrogen and other atom are within a molecule. ठीक है? एक ही मॉलिक्यूल के अंदर है. Example is something like ortho नाइट्रोफिनॉल. अब ऑर्थो नाइट्रोफिनॉल के अंदर ये हमारे पास ये है, ये हमारे पास O है. Here we have H, here we have N, and here N has double bond O, and here it's O. So here it is going to be this. ठीक है? ऑर्थो नाइट्रोफिनॉल या फिर salicylaldehyde. Okay, here we have C, H, double bond O. Here we have O and H. Okay. Then we have intermolecular. इंटरमॉलिक्यूलर. इंटरमॉलिक्यूल का एग्जांपल हम ले सकते हैं वाटर का. ये ऑक्सीजन है, ये हाइड्रोजन है, ये हाइड्रोजन है. एंड देन वी कैन हैव हियर इट्स ऑक्सीजन, हियर इट्स हाइड्रोजन, हियर इट्स हाइड्रोजन. एक बात का ध्यान रखना, ईच वाटर मॉलिक्यूल इज केपेबल ऑफ फॉर्मिंग 4 हाइड्रोजन bonds, 2 from the lone pair, 2 from the hydrogens. So here it's going to be something like this is oxygen, hydrogen, hydrogen. Here we have oxygen, here we have hydrogen, here we have hydrogen, and here we have the hydrogen bond. Now this is the case of ice. and this is the empty space. Yeah. Now, because of this empty space, ice has lower density than liquid water at 0 degrees Celsius. नहीं बेटा, क्वेश्चन की क्लास हमारी स्पेशल क्लास पे है. Any confusions? So this is what we have as intermolecular hydrogen bonding and intramolecular hydrogen bonding. कोई confusion? Yes, Ananya, you can consider them the voids. Okay. These are what we can call as empty space, or these are also called clathrate. That is cages. Many of the molecules, many of the atoms, they get trapped in these clathrates and they are able to form clathrate compounds. Okay. That's what we have as the hydrogen bonding. That's what we have as intramolecular hydrogen bonding and intermolecular hydrogen bonding. Okay. Now here comes another word, polarization. Polarization. Okay. Polarization क्या है? Creation of poles. That is regions of high and low concentrations. समझ आ गया नन्हे सरकार everything? So creation of poles, that is regions of high and low concentration. That is what we call as polarization. Okay. Let us say we have an atom or a molecule or the ion. We have non-polar species. The species does not have any kind of charge separation. Let us say we get a positive charge near it. Positive or negative doesn't make a difference, but positive charge, let us say we get it. If we get a positive charge near it, then in that case, the electron cloud is actually going to get deformed. Okay. Now, this part is going to get a negative charge, and this part is going to become positive because it becomes electron deficient. So, this part becomes electron deficient, and that is why this becomes positive. ठीक है? Now, this deformation is polarization, and this becomes an induced dipole. Why it is induced dipole? Because this positive charge has induced the dipole in it. Earlier, it was not a dipole, but because of this positive charge, it has become a dipole. That is why it is called the induced dipole. Okay. Now, what is this polarization dependent on? There is something called polarizability. And that's what we have as the ease of polarization. How easily it can get polarized. Now, ease of polarizability किसके अंदर ज्यादा है? Less strongly the electrons are held. मतलब कि less effective nuclear charge, more is the polarization. ओके, जितना इफेक्टिव न्यूक्लियर चार्ज कम होता जाएगा पोलराइजेबिलिटी उतनी ही ज्यादा हो जाएगी. कान्हू नायक बेटा, वॉट एवर यू आर राइटिंग इज नॉट legible to us because we don't know this particular language. Okay, less strongly the electrons are held, less effective nuclear charge, more is the polarizability. Ananya Sarkar, do you have that much time? If you have that much time, perfectly fine. Otherwise, I would suggest that whenever you are watching the lectures, clear your doubts right there so that after the lecture you can start doing the questions right away. Okay? If you have the time for self study, all the best. Because you don't do self study, that is why we have to take such lengthy lectures. Okay? Ananya, I was just looking at my profile and I found that you had given me a hat long ago, an year ago, isn't it? Ananya Sarkar had given me, no, you have given me 3 days ago. Radhika Mittal had given me 1 year ago. Yes, Prerna, you have given me a few days ago. Thank you. ओके, एक बार लैटिस एंथैल्पी एक्सप्लेन कर देंगे? बेटा लैटिस एंथैल्पी की पूरी डेफिनेशन है. लैटिस एंथैल्पी इज द एनर्जी रिक्वायर्ड to break a lattice into its constituent gaseous particles. That gaseous particles could be atoms, molecules, or ions. So that is what we call as lattice enthalpy. 1 mole lattice. Okay. So we talk about the ease of polarization. Less strongly electrons are held, less effective nuclear charge, more is the polarizability. And what we generally consider is more. अच्छा एक बात का ध्यान रखना इससे पहले की anions are more polarizable than neutral species. ठीक है? And cations are least polarizable. Is that clear? Cations are least polarizable because cations have very high nuclear charge, very high effective nuclear charge. Okay. Further, more surface area, more polarizability. If everything else is the same. More surface area, more polarizability. Okay. And more surface area is going to be something like more molar mass. Okay. So more is the molar mass, more is the polarizability. Anybody has any kind of confusion between polarizability? Any confusions in polarizability? Polarizability क्या होती है? Now, having talked about something like polarizability, let's talk about something called the polarizing power. That is capacity to polarize a species. And polarizing power depends on small size, high magnitude of charge. Small size, high magnitude of charge. नहीं अनन्या उल्टा बोलना चाहिए. Polarizability is directly proportional to surface area, but it is actually polarizability is a different context altogether. It depends on the effective nuclear charge. More is the effective nuclear charge, less is the polarizability. अब बात यह है कि अगर effective nuclear charge ज्यादा होगा तो surface area अपने आप कम हो जाएगा. तो it is indirectly related. ठीक है ना? अब अगर cation का surface area ज्यादा भी होगा तो भी वो कम polarizable होगा. So it is not just surface area, it is actually effective nuclear charge which determines polarizability. Okay, and it is effective nuclear charge which defines the polarizing power as well. Okay, higher magnitude charge or effective nuclear charge. So more is the effective nuclear charge, more is the magnitude of effective nuclear charge, more is the polarizing power. In fact, we can talk about something called charge density. What is charge density? Charge density is effective nuclear charge. And again by surface. Okay, so charge density is actually not the volume charge density, it is actually the surface charge density. So that is what we have as polarizing power. Okay, most often cations have the polarizing power and anions have the polarizability. Okay. Now, having talked about this polarizing power and polarizability, now let's get along with something called the London forces, the dispersion forces, or which are also known as weak van der Waals forces. Now, these are actually temporary dipole, temporary dipole interaction. Okay, so we have a species, a large species. Now, this undergoes polarization. Here we get delta negative, here we get delta positive. It could be induced or instantaneous. I told you that electron doesn't remain stationary, it keeps on moving. When the electron moves, then in that case, it can create instantaneous dipoles. Okay, so this is induced or instantaneous. Fine. Now, this dipole, when it interacts with another dipole, it is called instantaneous or temporary dipole interaction, and that is called the dispersion force or the London force. Now, these dispersion forces obviously are proportional to surface area. Actually, it is proportional to polarizability. So larger are the molecules or the species, more is the temporary dipole interaction. And this is example seen in, let's say, fluorine, chlorine, bromine, iodine. So here the forces increase, and with the forces, melting point, boiling point increase. Is this clear? So that is what we have as London forces or the dispersion forces, which are known as weak van der Waals forces. They depend on surface area. Okay. Now we have a very simple concept. Some people call it Fiennes rule, some people call it Fajan rule, whatever you want to call it. Now, this Fiennes rule or Fajan's rule give us the covalent character in ionic bond. Fajan's rule talk about covalent character in ionic bond. Now, how do we deal with it? देखो, the result is the same, but its approach is opposite of the dipole moment. In case of dipole moment, we consider the bond to be covalent, and then we talk about the shift of the electron. In Fiennes rule or Fajan's rule, we consider the bond to be completely ionic, and then we talk about the movement of electrons. Okay, here the bond is considered ionic, and then covalent character is considered. Okay, here we have the anion. This is the anion. Okay, and here we have the cation. This is positive, this is negative. Now, this is the complete ionic bond. But the cation has a polarizing power, and anion has a polarizability. And because of that, there is a deformation in the electron cloud of the anion. And this gives the covalent character. This gives the covalent character. Is it clear? So we have the factors favoring covalent character in ionic bond. We have the factors favoring covalent character in ionic bond. Okay. The first one, small size of cation. Small size of the cation. Second, high charge of cation. Okay. Third, non-noble gas configuration of cation. Now, non-noble gas configuration of a cation would mean the transition metal. When we talk about the transition metal ion, they have high effective nuclear charge. Okay, so this would mean high charge density. And then we have large size of anion. Large size of anion, and that gives us polarizability. And then, Sarkar, we are not taking any 3-minute break. We are just completing the class. We are just ending the class. Okay? Now we are going to do NCRT reading tomorrow morning, 10 o'clock. Okay? And today at 7 o'clock, we are going to have a series. We are going to have a bonding NCERT, and all objective questions in special class. So just remember, today evening, 7 p.m., we are having a special class in which we are going to do the bonding chapter questions. Clear? So tomorrow, 2 p.m. Botany, Swati Batra ma'am, 3 p.m. Zoology, Sachin Kapur sir, 4 p.m. Chemistry with me, 9:30 Physics. You are going to have. Join our Telegram channel for YouTube classes, PDFs, t.me/NEET Elixir. NEET UG subscription you can take using the code AVLIVE. हंसिका इसको पीछे करके देख लो बेटा. आराम से बताया था, बहुत इजीली समझाया था, थोड़ा पीछे करके देख लो. Okay, you can download the Unacademy app and you can go ahead with this. Unacademy.com/Anoop Vashishtha is my page on Unacademy. You can follow me there and you can join with it. Subscribe to the Elixir. Bye bye. Take care. We are going to continue with this. We are going to talk about the questions in the evening and we are going to do NCERT reading in the morning tomorrow 10 a.m. Is this clear? Bye bye. Good day.